Welcome to Detection Engineering at Scale, building high-fidelity security operations. I'm Andrew Krug, and I have the privilege of leading the security advocacy and research team at Datadog. We're the team that writes Datadog Security Labs and the state of insert thing here, research studies, if you're familiar with those. And I'm joined today by a fantastic co-presenter from one of our customers.
Hi, everybody. My name is Nathan. I am a senior security engineer at Riot Games. I have 6 years of experience in security. Been at Riot for about 4 years, and then before that, had two other years in 2 other companies. Before that, I was actually a software dev. At Riot, I'm on their security operations team, where we basically do all the blue team stuff that you can think of, threat hunting, detection engineering, threat intel, forensics, incident response. I can keep going, yada, yada, yada. Personally, I love building tools which make our life easier. It's probably the software dev in me a little bit. And outside of work, I have 3 cats. And a fun fact is I used to coach professional Overwatch. Back to you, Andrew.
Great. So before we get into this, just super curious, how many folks do we have that are in security roles in the room today? Like your primary job is security. And how many Datadog customers do we have in the room today? You're already using Datadog. All right, cool. Thank you so much. So we're here today to talk about detection engineering. And put simply, detection engineering is the act of writing detections to find threats and misconfigurations. Today we're going to talk to you about detection engineering as it relates to detection as code, which is the act of applying SDLC principles to authoring detections. Getting this right a very high percentage of the time, if you practice this, can be incredibly challenging. So we're going to share a little bit of advice on some best practices here and what's worked really well for Riot. But first, let's just kind of examine a little bit of the problem space that we're working in here and we're trying to solve with this detection as code approach. And that's that really we're all dealing with tons and tons of logs. And the slide says logs as infinite as stars in the night sky because that is generally representative of the number of systems that you could potentially be ingesting logs from in your environment today. So obviously, like you are all building on AWS, which means that you have at least 4 logs probably in your environment, and then tons and tons beyond that. But everybody has like kind of these staple logs that we're all dealing with, like AWS CloudTrail, workload security logs from your endpoints, network context coming from things like VPC flow logs, and now with AI platforms, tons and tons of logs coming from things like agentic workflows and platforms like Bedrock. So our goal at the end of the day, which sometimes we have to remind ourselves of when we're looking at all this data, is that we just want to detect when bad stuff happens. And that should be in a way that is contextual and actionable. So if you're not familiar with kind of the detection development lifecycle, this is the go-to detection development lifecycle by Hader Dost. It kind of details a few of the phases that folks go through, whether they're using a software development lifecycle approach or just manually building detections at all. You kind of go through the requirements gathering phase, like what is the thing that I want to detect? And basically for that, when do I set it at a high enough severity that I want to do something like wake somebody up? Then we design that detection, we develop it, and where this kind of falls apart most of the time is in testing and development. So how do we reliably know for an event that should never take place in our business that that alert is going to fire when we need it most? And how do we do that on an ongoing basis? And then as the application stack evolves, as the threat space evolves, at what point do we decide to actually retire that detection because it's no longer relevant? So that's where SDLC can be really, really helpful. And so we're gonna highlight a little bit of that when we get into the hands-on portion of the session. If you are doing manual detection engineering, and just curious, how many people are just like building alerts in the sim that you're in today? If you want to raise hands, yeah, quite a few folks building alerts manually. So if you're doing that, you are familiar with some of the challenges that come from anything that is effectively ClickOps. We have a lack of version control and audit history. We have siloed development in users that have access, so sometimes we don't even have shared visibility across the entire organization. We have inconsistent quality for those and output, and then they become increasingly difficult to manage at scale. So the more detections you have, the broader this problem kind of becomes, so long as you're doing it manually. So in order to address some of those challenges, security engineers began to apply SDLC principles. This is no surprise because we're really just taking the things that we've learned from like DevOps, DevSecOps factory patterns, and we're applying them to writing detections and managing the lifecycle of those. So for all of these things, we're going to introduce things like version control and peer review. Obviously, in order to do that, the SIM that you're using behind the scenes has to have some kind of mature API in order for you to interact with that. We're going to talk about testing and validation. And like for some complex incidents, the validation of specific types of alerts might involve very long windows of time. So we're going to give some advice on just like how do you backtest those rules against historic data. Then we put those in CI/CD. We make sure that they're syntactically valid. And then another big concept here that we're going to discuss is reusability and modularity, because you might be detecting the same things in a number of systems just with one minor change. So the more that you can modularize that, obviously the fewer potential errors you're going to have in that code. So the goal of a detection engineer is really to write a perfectly accurate detection. And we'll get into like what I mean when I say perfectly accurate here in just a second. But in practice, this is almost unachievable 100% of the time. So that's something that we have to accept going into it, that we need to adopt almost a good enough for now mindset. So some terminology here that you should be familiar with if you're in this space is that we have this notion of perfect recall in detection engineering, and that means that the system identifies 100% of actual malicious events with 0 false negatives. And that sounds pretty cool in theory, but in practice, this is one of the most challenging things to do in detection engineering. Then we have perfect precision. So that means that we can detect a bunch of things, we group them into a basket, and then we throw out the false positives to increase the fidelity of that detection. So it only fires when a genuine malicious event has occurred. And if you're following the AI space, this is where LLMs are really, really helpful for folks. And the reality is that most people are writing rules that are somewhere in this middle ground, because we want to detect an amount of time that's meaningful with some confidence, and we're actually most of the time pretty okay with a low rate of false positives. But if we have too many false positives, that's where we get into the noise problem, and people start to lose confidence in the detection system. So the reality is we're always making trade-offs, and I can't think of a better analogy than this one here, where you could think of maximizing recall as a smoke detector analogy, where you want it to go off, you're kind of okay with some false positives because the consequences of it not going off are maximum risk. And then in the case when you're writing an alert that wants more precision, you can think of something like a spam filter, where we actually want to avoid false positives almost all of the time because somebody might miss a message. So we need to find the middle ground, which means understanding for the thing that we're trying to detect, what is our tolerance for false positives? How can we use historical data to gauge how that rule will perform and then further tune it to reduce the false positive rate? We need to continuously monitor the rule performance for false positives and see how that's trending in real life once we move it into the production SIM environment. And then we need to determine the impact of tuning that rule over time. Because like maybe the log sources change, maybe the nature of our application changes, maybe there's another security control that does something like reduces the volume of events coming into that thing. So now I'm going to hand it over to Nathan from Riot to talk a little bit about how they have leveraged the Datadog Cloud SIM to build a detection as code platform.
Thank you, Andrew. Okay, so today we're going to talk about 3 different challenges. First one we're going to talk about is sort of relates to what Andrew was talking about earlier, about like logs as the infinite sky, right? These are challenges that we've sort of dealt with and sort of solutions that we've come up with for them. So the first one, right, is if we log too much, right, that's obviously going to cost a lot of money and it's going to break the bank. But if we log too little, then we lose signal because we can't write detections because we don't have the logs we need. So how do we find this perfect ground of being able to log everything we want and also being able to sort of like filter what we don't need but maybe still keep it? So this is where this sort of comes into play, SIM optimization. We had this problem. This is sort of the 6 points we have for sort of what we want criteria for trying to solve this. So the first one is we wanted to filter early and save big. So we want to be able to filter before stuff actually goes into our SIM. We want to be able to adapt on the fly, and we want to be able to normalize for clarity. We want to stay resilient, we want to scale with confidence, and we want to enforce data hygiene. So I'm going to go into a few of these in a little bit more depth, right? So filter early, save big. Why does this matter? Well, when people send us logs, sometimes they mess up. And what I mean by mess up, they send us way too much. And then what ends up happening is our SIM explodes in a sense of like we're ingesting a lot of data, we're indexing a lot of data, and that costs a lot of money, and that's not good. So we need a way to be able to filter data before it actually gets into our SIM. Adapt on the fly, scale with confidence, right? This sort of goes in hand with what I just mentioned, right? We need to be able to, if people do send us a lot of data, we don't want our like infrastructure to break. We want to be able to scale. Okay? So in a minute, we'll look at sort of a infrastructure diagram of everything is sort of built on AWS native services. It was actually built by a coworker on a team called Nathan Martini. I'm one of the engineers that helps maintain it. And the last thing I want to sort of talk about is enforce data hygiene. So what I mean by this is that sometimes we want to make sure that when we're getting these log sources, we put important tags, right? So we care about maybe like environment. So we want maybe to know if the log source is prod, dev, or something else. Or we maybe want to know about a log source owner so that if something happens to that log source, we actually know who we need to contact to figure out what's going wrong. So let's sort of jump ahead. Let's look at this infrastructure diagram. So what I want to call out first is sort of top left. You can see public collector, private collector. So this is where sort of the journey starts, right? We have situations where we have third-party vendors, tools that want to send us logs. We also have situations where we have internal teams that want to send us logs. You can probably think of, our networking team that want to send us pan traffic and pan threat logs. So we need to be able to have collectors that work for both public and private. So teams would basically send it there. We have specific ports for different type of log sources. It just helps keep things a little bit organized. And then behind that is essentially an auto-scaling group that is running Vector. So if you're not familiar with Vector, Vector is an open source log shipper with transformation functions written in Rust. This is actually by Datadog. I really, really like it. So after, anyway, logs get sent to auto-scaling group on Vector, it then goes to Kafka, right, for back pressure. And then from there, it goes to an ECS container service that's also running Vector. However, with this one, what's happening here is this is where we're actually going to be doing a lot of our filtering. So this is where we might say, hey, like, you are blasting us with data, and we need a quick way to, stop that thing from blasting us. Well, we're going to be able to make a change here and be able to drop data. Or here, we might be able to add some tags. Then from here, stuff goes to Datadog. Then from Datadog, goes to our sort tines. Then from there, goes to Jira. And then eventually Slack, because we all love Slack. Slack Ops is a great thing. One more thing before I move on from this slide I want to talk about is sort of like what Andrew was talking about, right? With CI/CD, infrastructure as code, PRs. When Nathan Martini designed this, one of the really cool things he added was that a GitHub repo that basically stores our vector configuration files. So whenever we want to make an update to our vector configs, all we have to do is literally make a new branch, make a PR with the file, put it to the branch of with the environment, staging, prod, and push it. And then we even have monitors and whatnot set up in Datadog to actually see if stuff actually got pushed successfully and whatnot. So let's sort of go a little bit more into vector, right? So we talked a little bit about what it is. Let's sort of look at an example of what a vector configuration looks like. So how I like to sort of describe vector, if you're not familiar with it, is there's like three main things in it. There is the source, right, where you're sort of getting data from. There's the transforms, and then there's a sink, where you're going to send data. Pretty straightforward, I feel like. So this example we're looking at right over here, let's sort of pretend that Vector is running on that laptop right over there doing the presentation. Let's pretend it's maybe running as a service or Docker or whatever you would like to run it as. If we look at this example here, it's saying source is Windows event logs, and specifically grabbing security logs. Cool, so it's grabbing security logs. What is it doing with it? Well, let's look at transforms. So what it's doing now is it's actually adding a field called log source owner, which is the value security team. Cool, as I talked about before, tagging data. Next, what it's doing is sync, which in this case, it's sending it to Datadog. So this is like a very relatively simple example. Next, let's sort of like think about how we'd want to do something with maybe S3 data. So let's look at an example with CloudTrail logs, right? Most people have CloudTrail logs, they send it to an S3 bucket, and they want to do stuff with it. So in this example, a little bit more complicated for a source. We have AWS S3 as a type, we have a bucket, we have a region, and then we have file prefix, and then obviously, codec, JSON, and whatnot. So we're grabbing our S3 data from the bucket. We're then doing another transform. However, in this situation, we're actually doing a delete on an event version. And this is honestly just an example to sort of highlight that we can do transforms, like I talked about earlier, where if we want to delete fields, let's delete it, right? Certain log sources sometimes come in with fields that are quite big, not useful, and honestly, we just don't need it. So why even ingest it, right? If it's not going to be useful in our detections, why would we want to keep it? And not even detections, incident response, or even threat hunting. And lastly, like the previous slide, sync going to Datadog. So hopefully from these two slides, you sort of got an example of what vector sort of looks like. I will be honest, our vector configuration's a little bit more complicated. We probably have a few more sources and maybe one or two more syncs, but this should give you a good idea. So now let's look at a summary of what we sort of just covered. So in summary, right, we built something that is built for speed. We wanted to collect all our data, and we wanted to be able to send anywhere. So an example in that infrastructure diagram where we saw that ECS, it's sending to Datadog. Realistically, we could take that and send it anywhere. We saw in the end with the vector configuration, the syncs there, so we could point that other places. This allows us to be flexible, which is honestly invaluable. Next, we can filter at the edge, which we talked about. We want to be able to enrich on the fly. We saw examples of being able to add tags to log sources or fields to log sources, as well as delete stuff. And then we want to be able to stay in control, which is our infrastructure as code, our PR, being able to PR stuff, and it's flexible by design. So what's the next problem, right? So we've talked about this whole thing of like log ingestion, right? Now the question is, are we going to actually, all this data that's going to Datadog, are we actually going to ingest it all or index it all? How is that going to work, right? So the answer is, right, it's going to depend. And I'll give an example of a log source like pan traffic, right? That's a pretty noisy like log source. Do I need that for detection engineering? Do I need that for threat hunting? Do I need it for incident response? Well, probably may not need it for detection engineering. So then do I actually need to index it? But if an incident happens and I need to look at my pan traffic logs, I might need to look at it later. So how can I handle this? And this is where sort of storage and rehydration come into effect. So what is storage and rehydration, right? Storage, you can even call it archiving if you want. But in very simple terms, right? Basically what's happening here is we're grabbing a log source and we're just going to send it to an S3 bucket. And then from there, when we want the data, we're going to rehydrate it from an S3 bucket. So now, let's say we're looking at our pan traffic logs, and we're like, okay, cool, we got these. Let's ingest them. Let's not index them, because it's expensive. When we have a threat hunt that we want to do, or we have an incident so that we need to look into things, then we'll go in and we'll actually pull it back from that S3 bucket that we archived it to. So let's look at a deeper example of what this sort of looks like in the GUI. I honestly really like Datadog's GUI. I think it's done pretty well. So at the very top right, we can set an archive name. We can specify the filter based off a query of what we actually want to send. What's nice about this part is that we can actually be very fine-tuned on what we want. We're not just sending a log source. We can go even doing a sub of that log source. For this example right over here, we're looking at pan firewall, but then we're particularly choosing type global protect, aka VPN logs, which realistically, you'd probably index, but for compliance reasons, you probably need to keep your VPN logs for a long time. Next, we look at our archive type. So you probably set up an IAM role for AWS. You then look to set up an AWS account, S3 bucket, path, choose your storage type. Cool. So now that we got a little understanding of like how we're storing these logs, let's sort of look at like a sample use case. So this is a rough use case. So let's say we've got questionable activity from X user. Let's pretend that X user is me. Let's say that I'm malicious or I'm doing weird things. And we need to backtrack, what IP address I had for my VPN sessions because I'm working remote, and we need to figure out what I was doing, and then was I allowed to do that, right? So in this case, let's say I needed to rehydrate logs to be able to do this. So let's look at what that would look like in rehydration. So on the right side again, we can see the rehydration GUI. So in this situation, you can see on the very top, what we're going to do is we're going to rehydrate a time period. So if I know that I was doing some weird stuff maybe 2 days ago, right? I'm going to focus on that time period. Next, we're going to choose the archive name, and then we're going to choose the actual query, right? So this is the part, these two things I want to talk about a little bit more. The time period and the query. Normally when you do rehydration, the biggest problem is it takes a lot of time. I've done rehydrations on other tools and products, and it's taken me probably 5 to 10 hours. If we have an incident, 5 to 10 hours is a long time. That's a problem, right? So what's nice about this with the time frame and the query is I can now shorten that, right? Why? Because if I know the time period I want, that's going to reduce the amount of logs I want to rehydrate. On top of that, if I know that I'm only looking at me, I can do something like at user.name_npitchiconi at riotgames.com and only get my logs. So now again, I'm going from getting a bunch of VPN logs, right? I'm shortening it by a time frame and then also the user. So this generally will take maybe like 5 to 10 minutes. That's a lot more reasonable in an incident response scenario. So what's another option, right, instead of rehydration? Andrew, would you like to talk about archive search?
Yeah, thanks. Sometimes you don't want to rehydrate all of the logs in an investigation back into an index just to be able to see if the needle even exists inside the haystack. And I think this is one of the most challenging things in managing a logs platform is as a business, you're constantly having to balance the trade-off of cost. What do I keep in the hot index? What do I keep in an S3 bucket? What do I send to something like Flex Logs or a colder storage to optimize further? So Datadog Archive Search is a new feature which allows you to run a search query off of data that lives in a platform like S3. And that's really, really cool for threat hunting or forensics or incident response because all of a sudden now we can do an investigation on that slightly colder storage that is much less expensive, and then we can see if it's worth it to pull those logs back in or rehydrate the logs to go a little bit deeper. So Archive Search is a net new feature that's available. The docs are linked there in the slide.
Thank you, Andrew. So let's talk about challenge number 2, right? So we just talked about logging. We talked a lot about ingestion and dealing with indexing and ingestion. But the reason why we want to start with that is because detections are written on logs. But now let's sort of get into more of the core issue of why we're here, right? Detection is code. And Andrew did a really good job in the introduction, sort of talking about what detection as code is. So as the challenge says, right, detection quality doesn't come from more rules, it comes from a better process. So before I go into this a little bit more, I want to state that when Riot started using Datadog, we didn't really do detection as code. We were building rules in the GUI. And I'll be honest, I really still like the GUI. And we'll see why when we built our processes that we still sort of use the GUI and we sort of found an interesting way to do detection as code still. So let's do a quick summary again of just what detection as code is. The core principles being version control, automated testing, collaboration and review, and automation CI/CD. So I want to talk a little bit more about the collaboration and review. One of the biggest issues with just not doing detection as code, in my opinion, is simply typos. Typos, testings, people just making mistakes, because, that happens. I have definitely written detections that I thought worked, but I mistyped something. I maybe sent the detection to the wrong notification. Maybe it was going to dev when it should go to prod. And that type of mistake can honestly be pretty critical, right? If I was writing detection that I knew for some malicious traffic that could happen in the future, and all of a sudden that detection will not work anymore, that's a problem. So this is where that collaboration and review part really comes into effect with the whole GitHub part, with the PRs, right, and reviewing. Next part is the automation testing, or automated testing. In a little bit, in a second, we're going to see sort of a demo of our whole process, and we'll talk a little bit about what this automated thing looks like. We're going to see sort of some basic Python scripts being run to basically doing some simple validations to make sure these rules are up to our standards in terms of things that it should have, such as maybe minor techniques and tactics, environment tags, make sure the rule name makes sense, and other small things like that, as well as the rule is actually valid itself. So without further ado, let's sort of get straight into it. We're going to talk about how we create a rule. So right now, we're in the Datadog GUI. We are going to go straight, and we're going to go straight and look to create a rule. So right now we can see that all the rules that are enabled there's nothing there. There's nothing. So we went first. We're going to enable one. We're going to focus on a threshold rule. There's a bunch of different types, but we're going to keep it simple. We're going to go and we're going to focus on a rule. We're going to look at CloudTrail, right? Where AWS reInvent. Got it. Should do CloudTrail. We're going to focus on stop logging, so because that would be weird. People shouldn't be stopping logs. And then we're going to group by an account ID. Next thing I want to talk about is that preview matching logs. So this is right in the bottom. That's a very helpful thing that basically will allow us to do some testing on basically if things exist for that query. And one of the reasons why I like the GUI. The next thing is we're going to define our rule condition and say, like, if anything hits or greater than 0, then alert. Then we're going to add a rule name, and we're going to add a description. The other thing I wanted to mention as well is at the very bottom, right after this is done, we're going to start adding tags. So this is part of that part where it's good practice, right? When you're security operations, you probably want to start using MITRE tactics and techniques. And that's good for tracking purposes to see where your general coverage is. So we're going to be looking to add both of those. We'll also be looking to add my environment tag as well. It'll take 1 second. My typing is unfortunately a little slow. But while it's happening, the other thing on the bottom you can see is create suppression. And I'm not going to go into this today, but we've actually also CI/CD'd our suppressions as well. And that's a really helpful thing too, because we basically linked suppressions to detections. And again, when you see a little bit, and when we go to the next slide, everything's in an IDE, and everything is just managed. But what's nice about this approach so far is that we're literally in the GUI. And when we're done with our tagging, basically what we look to do is we look to actually export the rule. So we go to the top right in a second. That's suppressions. So we'll go to the top right. We'll look to export it. That grabs us JSON. And the big important part here is we're actually going to not save the rule. We're going to cancel. Okay? So now we've got the rule in JSON. Let's look at how we're actually going to go about deploying it. So now we're in our IDE. You can see there's a folder called CloudTrail. In a second, I'm going to basically drag the rule in. I've named it a little nicer because the name was a little not great. So there we go. We got our rule. We're going to open it up. Oh, look at that JSON. Very nice. It's got all the configurations that I just set up in the GUI. I don't have to worry about it at all. It's all there. So now what I want to look to do is actually look to deploy this rule through our CI/CD process. So we're going to do Python, manage PY. We're going to do a validate. So this is where our validation comes into effect, right? Where we're looking to see, if there's any issues. And note right off the bat, we have an error. It's saying that we don't have a CI/CD tag. So right away, I'm going to make a CI/CD tag. Now, what is a CI/CD tag? This is basically a tag that we use to link our rules that are in our GitHub repo or disk, basically to what's in Datadog. We have to have some state, right? So this tag is the one that helps us control that. Next, we're going to look. We got our ID. Let's go straight and let's look to deploy it. So we're looking to deploy detections. So now you can see it's reading local disk, looking at the JSON. Great, it's looking good. Oh, great, it's creating a rule. So now, should have created a rule. Let's swap back to the GUI in a second. Let's do a quick refresh. So right now we can see there's nothing there. So let's do a refresh. And we should see the new rule in a second. And there it is. Wow, very cool. So let's look at the tags. It's interesting. So we got the CI/CD tag. We see a CI/CD hash tag. That's interesting. And then we see the environment. We see a managed SecOps. Managed SecOps tag is very important. We'll talk about this in a bit. But the CI/CD hash is also important. This is how we're able to actually tell when we update rules, which we're going to see in a second. So now that we created a rule, let's talk about updating, right? Let's just do a really simple example for updating. Let's just add updated to the rule name. But what's going to happen here when we do this, right? That CI/CD hash, that tag that we added, the logic is quite simple if you think about it. We're just going to compare what's on the local versus what's in Datadog. If there's a new CI/CD hash, right, or there's a difference in hashes, then obviously you have a different rule, so then you're going to update it. It's not pretty straightforward, and that's sort of how we wanted to design this, is make it as easy as possible. So we're going to do a validation. Looks like it's good. Let's go straight and deploy it. So now we're looking to deploy. It's taking a second to read, and then now, note, right over there, says updating. Cool, so now let's go make sure in the GUI that it actually reflects this. So there we go, we see it's there. Let's do a quick refresh. And there we can see the title right over there. It says updated. Nice, it's exactly what we want. So now we've been able to create a rule, update a rule. But what about deleting? Now we don't want the rule. Let's say it's a bad rule for some reason. How do we go about that? Well, this is a really simple one. If we want to delete it, let's just delete the file. So what we're going to do is go over here in our IDE and delete it. Now, one thing I want to clarify, right, is I'm doing all this in the IDE, right? Normally, this is done, a lot of the commands that are happening here are done through CI/CD. What I mean by that is it's done through GitOps, Jenkins. I'm just doing it in CLI right now because it's a bit faster and easier to show. So anyway, we're deleting the file. We can see that it got deleted. Let's now go back and let's see what this looks like. Yeah, the rule's there. Let's refresh. Quick refresh. And the rule is gone. Awesome. So now we've sort of seen again how we create rules, how we update rules, and how we delete it. So let's talk a little bit more about how we actually try and enforce this. So what do I mean by this? So, because the fact of the matter is, if you notice in the GUI, someone, by mistake, could press save. Mistakes happen. There's also situations where out-of-the-box rules turn on and they're auto-enabled. If that happens, what happens to our CI/CD state? Now we're going to have rules that are enabled that we don't actually want, right? We're not ready to turn them on, or they're just mistakes. So we built a very simple automation, which basically goes and pulls all the rules that are enabled in Datadog. It then checks those tags, and it looks for that manage SecOps tag that I talked about. That tag is added if a rule gets deployed through our CI/CD process. If it finds a rule that is enabled that does not have that tag, then it basically notifies us through Slack, and it auto turns that rule off. So this is a good way for us to make sure that our state is, always working. It's always exactly what we want and what we expect. However, now, let's say we have a security incident. Are you telling me that during a security incident, we're going to have to go through that whole CI/CD process to make a detection? I don't know how I feel about that, right? That doesn't sound that great. Doesn't sound fun. Realistically, honestly, it wasn't that bad. But when you're in a security incident, you want to be able to do things fast, right, and quick. So how can we deal with this situation? Well, we're going to sort of hack the system. What you're going to do, right, in a break glass situation, security, and you really need to make a rule and you don't want to go through a CI/CD process, you're going to make the rule, just like we saw initially in the GUI. However, you're going to manually add the tag manage SecOps. This way, the automation that we built will not turn it off. And obviously, we know this is a hack, and there's a little bit of trust, right, in the analysts to not abuse this. And that's something that we're okay with, right? We're building this for us. We trust ourselves, right, and to know to not abuse this. And when the incident's done, we're just going to go to the rule, export the JSON, do the things we did with IDE, and then boom, and we should be good. So now that we talked a little bit about this, rules, let's talk a little bit about out-of-the-box rules and how we sort of handle these at Riot. So out-of-the-box rules are great, and I really do think that's important, and I want to clarify this a little bit more before I talk about this flowchart. When we look at rules, right, we want to make sure that they work for our environment. And what I mean by that is if I turn on an out-of-box rule, I don't know if it's going to be loud or not. So it has to go through a process, right? And this is what this process looks like. What we'll do is we'll grab our rules, and then we'll basically test them. We'll grab the queries. We'll do that. Something in the future we're actually looking to do is actually use a historical engine Datadog has and build an automation that basically will go and grab all the out-of-the-box rules that we care about that are disabled and run a query and check the last 90 days and see the hits. And then based off that, we already know with confidence certain rules, this is hitting 0 in 90 days. It's an interesting rule. We can probably just turn this on right away, right? So that's part of that evaluation rule. And then from there, it's either enabled or disabled. One other thing I forgot to mention a little bit earlier, but in the previous automation that we had, where we were actually going and disabling rules, when we disable a rule, we actually send that rule information to a spreadsheet. And that spreadsheet keeps track of all the rules we've disabled. Why? Well, we have monthly syncs where we basically go through those rules and discuss as a team, hey, is this rule important? Oh, it is. Oh, this rule query makes a lot of sense. Let's just look to turn this on. Oh, this rule makes a lot of sense. They've already done the hard work for that query logic. We just need to tune it a little bit, add a few fields to make it work for us. Let's do that. Okay, so hopefully that makes sense. Let's go a little bit more into it, right? So in summary, the challenge of our out-of-the-box rules, right? Alert fatigue, normalization mismatches, coverage gaps, maintenance, and lifecycle. But, right, like I said, they have a lot of value, and I don't want to diminish that. A lot of the out-of-the-box rules a lot of the rules we actually have in Datadog are out-of-the-box rules that we've taken and just straight up enabled, or we've added some slight additions to that. So the biggest thing is you need to pair it with an activation plan. Okay, so now we've talked about detection as code, talked a lot about logs. Let's talk about my third probably favorite topic or challenge, which is behavioral detections. And I'll be honest, like detections and building detections themselves probably could be its own big talk, right? But I wanted to do a bunch of small little things because it makes it more fun. And hopefully you're learning a bit. So behavioral detections, they're good, but they're noisy, right? Let's talk a little bit about this a little bit more. So here's a fun picture, right? It's a behavioral analyst. You're observing behavior, but is it true or is it not? So let's look at an example of Okta, right? If you're familiar with Okta logs, Okta actually has inbuilt behavior logic. So it literally will tell you, if someone's doing stuff, is that person in a new city, new country, new device, new geolocation, IP, state, velocity, and then it gives you a risk level. Ooh, a risk level. We love severity, right? And then it tells you, what's going on. So we, want to test this out. We made it around basically stuff that our risk level is around higher critical. And we made a rule off this. And this rule basically says that in 1 week, we will get 22 detections for this. That basically equates to 3 alerts a day. And realistically, honestly, if it just happened like one day, it probably wouldn't be that bad. But as it keeps, the next day starts, you're like, oh, the alert's happening again. Oh, the next day happens. The alert's happening again. You're going to starting to get really annoyed, right, by the same alerts that just keep popping up and popping up, popping up. So this is sort of the problem, right? The issue, though, and it sort of leads into the next source I want to talk about, which is guard duty. So guard duty can be really noisy, but I'll say a big, big but. If you, let's say, have this first example right over there, unusual IAM policy creation, 72 hits, right? If one of those is a true positive, and that is an incident, you need to know about that, right? You can't ignore that. But are you going to tell analysts like me to triage 72 alerts? Probably not, right? We need to find some way of dealing with this so that we can still actually get that signal, but find a way to fine tune. And obviously, you could do fine tune. You could do a lot of things where you grab the detection, you maybe change severity and some stuff like that. But we came up with a solution that I think is sort of interesting, and that's what we're going to get into right now. So, next thing, we're going to talk about observing behavior. Notes the third hand on the notebook right there. So, let's look at our Signal Explorer. So, in exactly 1 day, we have 499 signals. That's weird. I just told you that we don't want to have a lot of signals. Why do we have 499 signals in 1 day? That's crazy. But if you actually look a little bit more at the color of those little bars, you'll see a lot of that is gray, right? A lot is gray. So what's actually happening here is we evaluate our behavioral detections that we see that might be noisy, and the ones we think that are high fidelity or valuable or we can fine tune, we'll keep them. But there are certain ones that are really noisy, but we still want to keep that for some type of correlation. So we'll turn those rules to info alerts. So let's sort of see what's going to happen here when we turn those into info alerts. So before I get into this, I sort of want to talk about something a little important about alerts and detections. Generally, any alert has a few fields, right? They have IP address, they have host name, they have username, they could have a user email, they could have an AWS principal, right? And that's really important because you can use those fields to correlate across other log sources or other alerts. Emphasis on other alerts. So let's sort of look at the diagram on the right. Let's say we get an alert from Datadog. It's a medium, which is, medium alert, cool. It's an Okta potential brute force. And to be honest, that's also could be a noisy alert, right? People forget their passwords, right? And they go in a lot, and then all of a sudden they remember. So let's say we grab that alert. It goes, then, alert triggers, it goes to our store tool. We then say, okay, that alert had a username. So user.name, let's say npitch.iconi. We're going to instantly do an API call to that Signal Explorer that you just saw, a slide ago. And we're literally the query that we're going to hit is basically user.name npitch.iconi at Riot Games. Are there any hits for that? If there are, okay, maybe we look to change this to a high severity, right? If there aren't, maybe we look to keep it as medium or auto close, and we can sort of make that decision. So this is sort of how we're actually using behavior detections or anomaly detections that are noisy, but we're still able to cross-correlate it and get value out of them. So let's sort of like take this and like up it one more level. So let's put it all together. So now, same exact detection, right? Octopotential brute force. However, now we're going to look at multiple different type of fields we can correlate. Or let's look at user agent. Let's look at IP address. Let's look at username, right? And then we're going to take those and cross-correlate that with other alerts, with other threat intel, with check authentication. And then combine that logic, and then from there we can decide if we want to alert, not alert, change severity. Cool, this is great. However, there's one thing I haven't talked about, and I feel like I have to talk about it because everyone's talking about it, and the thing is AI, right? AI is a thing. I think we're all aware of that. And the answer is a lot of this flowchart that I'm showing right now honestly could be done by AI. Like that whole correlation with the user agent IP, user hitting check alerts, check threat intel, check authentication, AI can do all that for you. Very simple AI agent. The combined logic, you might want to like AI output what you want, and then you make the decision on what you choose to do. But what I really want to clarify that's really important, and I want you to make sure you understand, is you still have to tell the AI what to do. You have to still know that, hey, we have to have this idea that AI checking other alerts and looking at these fields. You need to tell the AI to go to virus total. You need to tell like the AI to check authentication and be specific about that. So you still have to have those fundamentals, right? And then from there, you can do some cool stuff with it. Awesome. Well, with that, I hope you enjoyed 3 different things I talked about. I'm going to pass it back to Andrew.
Thanks. Yeah, super cool implementation of what the world can be like when everything has excellent API support. So let's talk about the next phase of detection engineering, because after all, this is reInvent, and we kind of want to be a little bit future forward, and we want to look at how technology is evolving to help make these kind of jobs easier. So the first big kind of revolution in the detection engineering industry is the OCSF framework. I don't know if anybody has heard of OCSF before today, but it is the best effort I've seen in my career to normalize logs prior to ingest. So with companies like Datadog and AWS leading the charge, this has gained a ton of traction across the industry. The biggest benefit of OCSF is because logs are coming in a standard format with standard attributes. All of a sudden, the opportunities for low computationally intensive operations to correlate events become much broader. So like imagine, for example, that you had to write an account takeover rule. In the old world, we would write that account takeover rule for every platform that we were ingesting logs from. With OCSF, we can write a single account takeover rule that covers every platform that ships logs with OCSF. Nathan mentioned as well that Riot uses the open source log router Vector. Well, Vector has a cousin in the Datadog product, and that's called observability pipelines. And that's a part of Datadog that can do everything that Vector does and some more on top of that. This week at Amazon reInvent, we launched the OCSF processor for observability pipelines. So that's generally available today, and you can use it to take logs and transform them to OCSF, which is a supported storage format in the Cloud SIEM platform today. So don't miss checking out observability pipelines. And obviously, if you want to DIY it, Vector is an option too. Open source log router agent that can also do transformations. So the next cool thing on top of that is the explosion of detection methods, right? So if you look at this screen up here, Datadog supports a ton of different detection methods, including signal correlations, anomaly windows, and some of those behavior-based detections that we talked about, like impossible travel, or as I like to call it, you flew faster than Superman. You may have also seen our announcement this week that Bits AI SRE is generally available. Well, Bits AI also has a partner, and that is Bits AI Security Analyst. It's designed to automate and accelerate the work of human security analysts. So it primarily focuses on managing and investigating alerts in the Cloud SIEM. You can integrate it with automation and orchestration. So as mentioned, you could pair that with something like Datadog App Builder to carry out operations like doing a deeper investigation or session invalidation. And it works in tandem with other agents in the Bits AI family. So you can check that out in preview there at the link on screen. So to wrap here, the key takeaways are that detection as code is absolutely essential if you're building detections today, especially for platforms like the AWS cloud. Your data pipeline is absolutely everything. So like so many things today, data quality, data quality, data quality. That's going to just like really drive down your false positives and increase the precision in your detections. And then follow process, process, process. If you took nothing away from the section on how Riot's implemented this, it's that they have a very strong process that acknowledges some exceptions, but largely it's driving people down that paved road for deploying detections. And then embrace open standards as well. So, let's keep the momentum going with OCSF. If you're working with a vendor or a partner that doesn't yet support OCSF, that's a great thing to ask for, or a first issue to file on an open source project. So we started the session by saying the goal of detection engineers is to write perfectly accurate detections. With all this, it is mostly achievable. So if you have a cell phone and you want to take a picture of a single slide from the presentation, this is the single slide to take a picture of because it links out to a microsite with literally every single link to everything that you saw in the presentation, as well as ways to reach both of us after the session. And before we take questions, though, I do want to mention, I think one of the most challenging things when you're just getting started as a company is believing that tools like this can be accessible to you at your earliest stage. And so I do want to mention a new program from Datadog called Datadog for Startups, which gives Datadog Pro or up to $100,000 in credits during the first year. So if you're in that Series A or early startup stage, definitely check out the DDFS or Datadog for Startups program. And then if you're interested in our other reInvent launches, or you want to check out the deep dives on things like the OCSF processor, that's available at this link as well. And with that, we will go ahead and take any questions from the room. But I do want to thank you for being here with us today. And I want to thank our great customer speaker, Nathan from Riot, for giving an excellent demo.